Welcome to Geometry Pre-AP. We're looking at our new lesson here, 1-2. We're going to talk about segments and their congruence. Remember that when you come into class, always have your homework out and your postulate and theorem sheet once you get it, and have highlighters ready to use as we go over things when we're working in class and discussing stuff. All right. So for today's, we're going to look at different segments. And so our first thing we have today is our ruler postulate, postulate 1-5. We learned 4 postulates on the previous lesson. So this one says that if you have points on a number line, that you can give them coordinates like x1 and x2, and that once they have their coordinates, that you can find the distance between them by doing the absolute value of the difference. And so here's the formula right here. So it doesn't matter which order you go, actually. That you'll still get the distance every time, but it's the absolute value, because absolute value is the distance away from 0, and that keeps the value always being a positive number. So if I look here and I want to find the distance of 2 points on a number line, point D is at -6, so -6 minus point R is at 2. Okay, and so -6 minus 2 is equal to a -8 absolute value, which tells me the distance from D to R is 8. Now, if I would have done it in a different order, that would have been 2 minus a -6 absolute value, which is still just a positive 8, which when I take the absolute value is still just 8. So finding distance on a number line is just the difference, absolute value of the difference. Make sure you show your work and put your numbers in there. I know you could count on a number line, but if I put numbers bigger than what you can draw a number line for, you need to be able to show your work. And this class is always about proving what you know, not that you can do it, but that you can prove it. So take a minute to pause this video and find the distances of each one of these points and find from like A to D, E to H, F to B. So pause your video, turn on when you're ready to check your answers. Okay, so if we're going to do A to D, that is from -9 to D is at -1 absolute value. So that distance would be 8. If we go from E to H, that would be 7. From F to B, that would be 10. From C to G would also be 10. And from D to A better be 8 also, because you kind of did that one back here. The distance from A to D better be the same as D to A. So you better have got the same answers there. Remember that these are all distance on a number line. They should all be positive no matter what. Okay, so segment addition postulate 1-6 says if B is between A and C, then AB plus BC is equal to AC. Okay, and so you need to know that postulate, you need to know the words of it, and be able to state it in that form, where it's going to probably be a test question. So it is important that you have it done. So the word between says that if I have 2 points, so I have point A and I have point C, wherever it happens to be, and I connect them, that somewhere on that line, B has to be on there. So here's B. And so I like to Schroderize things, so I tell my students part plus part is equal to whole. And they call that Schroderizing because I just make it simple. But basically, you can remember this, but I need the letters known. And so this gets you the setup that you do in geometry. And after you use that setup, then it's algebra from that point on. So if you look here, we have DE is 8. So I got DE equals 8. I got ER equals 12. And I've got DR equals 4. So these are all distances. And I know that 2 distances that have to add up to equal 1. So which of these add up? So I know that 4 plus 8 is equal to 12. So if this is the part and this is the part, then this must be the whole, which tells me those are the points that are on the end. So 12 was ER, so that means E and R are the end points, which means D is somewhere between them. So that could tell you these are your end points. Okay, remember this little process is just kind of using the segment addition postulate. All right. Next, here it says S is between R and T. So we got to draw a picture. I know you know the saying, you probably have heard it before, that a picture's worth 1,000 words. Well, in geometry, I say a picture is worth 1 equation. And without that, you're not going to have an equation. So you need to draw the picture. You need to draw it on the paper, not mentally, but physically, so we can see what you're doing. So I've got 2 points, and I've got an endpoint. I don't know where that endpoint is. It's somewhere between them according to what it says. So point S is between R and T. So now that I've done this, I know which of my parts. So this is a part, and this is a part. And now from here, here is the whole thing. So once I know this, I can set up my equation. So RS is 2x plus 10 plus the other part, which is S to T, which is x minus 4. And it's equal to the whole thing, which is 21. And then you can solve this. So I want you to finish solving this for x. You'll get an x value. Then I want you to take that x value and I want you to plug it in and be able to tell me what RS is when you're done and what the length of ST is. And when you're done with that, you better make sure they add up to equal 21. All right, so now that we've got this done, we're going to go on to our next example. So here's our next example. Pause this video, work this question. Then when you're ready to check your work, turn it back on. Okay, so again, let's go through this process here. We have two endpoints. We got a point that's between them somewhere. So it says S is between R and T. Okay, so my RS is my part, so 3x minus 4. My ST is my x part, which is 14, equals 4x plus 4. Now, if you had that 14 on the end, you didn't read the problem at all. You just tried to do it exactly like the last one, and you're doomed to make mistakes over and over again because you're not reading for context and content to make sure you know how to write the problems out. So you better pay attention to that. You're just going to be guessing all the time. And so when I work this problem, I get 3x plus 10 equals 4x plus 4. I want all my x's on one side, all my numbers on the other, so I'm going to go to the right. So minus 3x, minus 3x, minus 4, minus 4. So I get 6 equals x. All right, so I know my x value. Once I have my x value, I can go back and plug it in, and I can find out what the length of RS is. And you should be able to do that also by plugging it back in and getting that distance. Okay, so these are the things I'm going to look for on your notes when you get ready to turn them in. All right, so here's a great question. Love these questions here. I expect to see a quadratic on every test throughout the year in the geometry class. So C is between A and B, and it gives you the segments. So pause the video, try to work this problem. And then when you cannot work it, I will put the work up here. All right, if you started the video, I went ahead and did the setup. So I had the part plus the part is equal to the whole. So 2x squared plus 2x plus 7x plus 2 equals 20. I started simplifying it, combining my like terms, and then I got it equal to 0 because this is a quadratic. Now I turned the video on here so that you can kind of follow along with me, and I'm going to go through the slip and slide method here. I love the slip and slide method. Lots of people do guess and check. It's just the method I use. So in the slip and slide method, I move that 2 into the back and I multiply it back there. So I get 2x plus, or I get x squared plus 9x minus 36 because I multiplied to the back. That's to slip it into the back, we call it. And then this is something most of my students know how to factor, so that's good. So I have an x and an x, and so I think of the factors of 36. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And so because that's a negative sign in front of the 36, I want to look which ones are going to subtract to give me 9. And when I start looking at my factors, I think this is the one that's going to subtract to give me 9. 12 minus 3 is 9. So I want a 3 here and a 12 here. And since I want a positive 9, the 12's got to be positive and the 3's got to be negative because no other way will they add it to be a positive 9 or subtract to be a positive 9. Now remember this is equal to 0. So I slip the 2 in the back. Now I got to slide it back in. So to slide it back in, I divide each one of these numbers here by what I multiplied to the back. So that was the 2. So I get x minus 3 over 2. Then I get x plus 6 now. Well, you can't have any fractions here. So the second one doesn't have any fractions, so I can leave it alone. The first one has a fraction, so I'm going to multiply it by 2 to get rid of that fraction. And that's everything there. So I get 2x minus 3, x plus 6 equals 0. Those are my factors. And remember in your summer packet, I asked you to do factor things. So that's my factors. But that's not my solutions. To get my solutions, I take each factor, like 2x minus 3, and make each factor equal to 0. So I get 2x equals 3, x is equal to 3 over 2, and x is equal to negative 6. And those are my solutions for what the value of x is. Now this question doesn't ask for the value of x, it says what is the length of AC? So now I got to plug it back in. So if I have AC equals 2x squared plus 2x, I got to plug each one in there. So if I start off, I'll start off with the one I know you're going to start, which is the negative 6 because it seems easier than fractions. So when I do this one, negative 6 squared is 36 times 2 is 72 minus 12. And so that's going to give me 60. So AC can be 60. That is a length. That's great. Let's try it again. I'm going to see. Let's see here. I'm just going to move that out of my way a little bit. Move it down here. Okay, I'm going to do it again. So AC equals 2 times 3 over 2 squared plus 2 times 3 over 2. So that's going to be 2 times 9 over 4 plus 3. That cancels with that. It'd be a 2. So that's 9 over 2 plus 3. And you know what? Let's take out that 3 and let's make that 6 over 2. That's the same thing as 3. And so that's going to be 15 over 2. Well, AC can equal 60 and it can also equal 15 over 2. Okay, well, this is a new kind of problem. Probably haven't had things like this before. There's two solutions. There's not always two solutions. Sometimes there are, sometimes they're not. How do I know if I have two solutions? I have to plug the x values back in and check and see if I have a solution that will work. If I would have gotten a negative value for AC, I can't have a negative distance, so I'd have to throw that x value out and only use the other value. I didn't say throw out the negative value. I said throw out the value. It could be positive, it could be negative. We don't know. Okay, so watch out for that. All right, so congruent segments. When you have congruent segments, we put these little tick marks on them. That means that they are congruent. We know segments that have the same length are congruent also. So think of congruent as meaning they have the same shape and they have the same size. And when we say that they're equal, we know their lengths and their lengths have the same length. So equal means numbers. Congruent means we know shape and size, but we don't know numbers. Okay, so in this diagram here, it says in the diagram, EF is equal to DE. So we show that by putting an EF mark. There's a mark right there on DE, and EF have one tick mark. It also says GD is congruent to DF. So that's a different set. So we choose a double mark, and DF is a double mark. So this is a way to mark different things congruent. So when you see that in pictures or when you give an information, you got to work it into a picture, make sure you mark things like that. It will help you to see stuff. All right, and that ends the conclusion of our lesson, and you will be able to complete all your work now. So good luck.